We are solving two simple questions of ray optics in this video. Let us see the first question. Which of the color of the light has longest wavelength? Right? So let me try to explain first that how do you get all these colors? When you pass a white light onto the prism, this is the angle of incidence with the normal. If there is no one, like a glass prism, it could have been gone like this in a dotted path, but there is a change of medium. Air is a rarer medium, this is a rarer medium, this is a denser medium, this is again a rarer medium. When a light ray is moving from rarer to denser medium, it moves towards the normal. That means this is the normal, it moves towards the normal this way, it strikes the other surface. Again this is the normal, this is again moving from denser to rarer. When it is moving from denser to rarer, it moves away from the normal. This is the normal, so it moves away from the normal this way. So the incident light is this, emergent light is this way. So there is a deviation between the incident light and the emergent light. Can check how much is the deviation is, just extend the deviated light ray backwards onto the incident light ray. So this is supposed to go like this, but it has gone like this, so this is deviation, angle of deviation. So the light rays get deviated when they are passing through denser medias, different medias. But how much it deviates again depends on the nature of that medium. It is found that among all the colors, violet deviates most and red deviates least. So this white light, while passing through this prism, splits into different colors, and that phenomena is called dispersion. Among them, the least deviated is red, the highest deviated is violet. In between we will be getting WaveGR. That's how a rainbow or a spectrum is formed, color spectrum is formed. So what can we notice is, among all colors, red has lowest frequency. As frequency and wavelength are reciprocal to each other, it has automatically highest wavelength. As the wavelength is large, it is able to travel for long distance without getting distracted or deviated much, as the deviation is less. That's why red is used as a danger signal also. And hence, who has the highest wavelength? The answer is nothing but red. That's the first question. Let's have a look at the second question. In total and reflection, when the angle of incidence is equal to critical angle for a pair of media in contact, what is the angle of refraction? So first of all, when this total and reflection or a critical angle happens is when a light ray tries to move from denser medium to rarer medium. When a light ray tries to go like this is angle of point of incidence, normal. This becomes angle of incidence. When it is trying to move denser to rarer, this dotted line is undeviated path, but when the light ray moves from denser to rarer, it moves away from the normal. So this is angle of deviation, D, who is greater than, angle of refraction, angle of refraction is greater than angle of incidence. If you keep on increasing that angle of incidence, somewhere for a particular angle of incidence, if you increase the angle of incidence, for a particular angle of incidence which is called critical angle, light ray grazes the boundary that is separating the two media, and the angle of refraction is 90 degree. That particular angle of incidence at which light ray grazes the boundary separating the two media is called critical angle. So he is asking, at the critical angle, angle of refraction is how much? angle of refraction is 90 degree. That's just the basic definition of a critical angle itself. That's how we have to solve this problem, right? Thank you for watching.